This is the video lesson for transverse versus longitudinal waves. The learning target for this lesson is, I am learning to compare the characteristics and behaviors of transverse and longitudinal waves. The success criteria for this lesson are, I can identify the characteristics of transverse and longitudinal waves. I can identify the behavior of transverse and longitudinal waves, and I can distinguish between transverse and longitudinal waves based on their characteristics and behaviors. So what makes a transverse wave transverse? So the motion of the medium in relation to the direction of the energy flow is what distinguishes a transverse wave from a longitudinal wave. So in a transverse wave, the motion of the medium in relation to the direction of the energy flow of the wave is perpendicular. So in a transverse wave, if the energy of the wave itself is traveling from left to right, then the medium is moving up and down, or side to side. It's moving perpendicular to the direction that the wave itself is, that the energy of the wave is moving. So if the energy is moving in this direction, the motion of the medium itself is moving up and down, or left to right. So in a mechanical wave, transverse waves only propagate in a solid medium. So think about in a string or in a slinky or something like that. In electromagnetic waves, so in something like light, which is what an electromagnetic wave is, electromagnetic waves are considered transverse waves also. So what makes a longitudinal wave longitudinal then? So again, in terms of the motion of the medium in relation to the direction of the energy flow, so if the energy flow of the wave is going from left to right, then the motion of the medium itself is also moving in that same direction. So it's moving, the medium itself is moving parallel to the direction of the energy flow. So if the energy flow is moving left to right, then the medium itself is also moving left to right. So in a mechanical wave, a longitudinal wave can propagate in a solid, in a liquid, or a gas. So a longitudinal wave can move through a metal or a wood, for example, or a liquid like water or any other kind of liquid, or in a gas like the air. And an example of a longitudinal wave would be sound waves. So sound waves are a longitudinal wave. And in a longitudinal wave, we have something called compression and rarefaction. So compression is where the longitudinal waves are compressed, and then rarefaction is where the longitudinal wave spreads out. So as the longitudinal wave is moving through the medium, it compresses the medium, and then it spreads out as it moves. So compression, and then rarefaction. So compression, rarefaction, and then compression, rarefaction, and that's how the wave moves through the medium. So remember that a wave is just the motion of energy. So a wave is just energy flowing through a medium. And so how that energy flows is what determines the type of wave. So if we want to talk about some examples of transverse waves, we can talk about, again, like waves in a string. If you tied a string to the end of a string to something and you move it up and down or side to side, that would be an example of a transverse wave. Also, surface waves on the water would be a transverse wave. So if you had a smooth pond and you threw a pebble into it, the rippling water from that pebble being dropped into the water, that would be considered a transverse wave. Some examples of longitudinal waves, the most common example is a sound wave, as I said earlier. But there are other examples of longitudinal waves. Ultrasound is an example of a longitudinal wave. So if you ever go into the doctor's office to get an ultrasound for some reason, that is a longitudinal wave, and there are some other examples as well. So here's a great question. Are water waves transverse or longitudinal? Now remember that longitudinal waves can propagate, only longitudinal waves can propagate through a fluid. So it seems like water waves would be longitudinal, But waves on the surface of the water obviously move up and down, right? We just talked about how throwing a pebble into the water makes the surface ripple up and down. So here's the thing with water. Water has a really strong surface tension. So the surface tension on water creates enough of a force for the water to behave on the surface more like a solid. So in water, we can have both transverse waves on the surface and longitudinal waves deeper down in the water. So we have both longitudinal waves, like a sound wave traveling through water. Think about whale song underwater, or like dolphins sending their little clicks and other sounds through the water to signal other dolphins, as well as transverse waves on the surface of the water. All right, everybody, keep asking questions. It's how you learn new things.